Right, we're going to discuss the difference now between true north and magnetic north as it applies to taking bearings from a map to the ground and the ground to the map. Basically, the essential rule that you need to keep in mind is that anything that you are measuring on a map is going to be according to true bearings. In other words, based on true north as a direction, as a cardinal direction, and everything is measured off true north and will therefore give you a true bearing as it would be on the earth. Okay. When you use a magnetic compass, in other words, when you're going to ground and you're taking bearings on the ground using a magnetic compass, you're no longer using true bearings, you're using magnetic bearings. And magnetic bearings, obviously it's like that because you are using a magnetic compass, which is measuring off the magnetic field of the earth, which deviates from true north. So magnetic north is true magnetic north is in Churchill in Canada, and of course true north is at the top of the earth where it rotates about the axis. So you need to make an adjustment when you go from a map to the ground or from the ground to a map in terms of your magnetic reading or bearing or your true bearing. Okay, so the magnetic bearing will deviate, called the declination, depending on the area, either to the west or to the east of true north. And that will depend how much it deviates, depends on where you are and which part of the earth you're on. So you need to make adjustments for that. And there are certain rules as far as making that adjustment is concerned. If you are measuring bearings or converting bearings from true, magnetic or ground bearings to map or true bearings, then you need to, if it's a western declination, you need to add, rather subtract a value. Okay, so if you have, for example, a bearing of 90 degrees on the ground, in other words, that's your magnetic bearing, and the declination is 20 degrees, and you move onto a map, you're going to have to subtract that 20 degrees to get the true bearing, okay, which would be then 70 degrees. And of course, going in the opposite direction, you've got to reverse the process, and there you would be adding 20 degrees to get your magnetic declination. And if you have an easterly declination, it's the total reverse order of what I've just explained. Okay, so on the top of this map, north is towards the left-hand side in this picture. Okay, in this video, if I move down and I look at the compass, I focus on the compass, you'll see that it's the magnetic arrow is seated directly in the box there, the red box, okay, and it's pointing directly north, and so is the direction of travel arrow. It's all pointing directly north, and it's all pointing to the top of the map. Okay, if the magnetic north coincided with true north, this is how you would use your compass. The compass has been basically put in the same direction as the true north for the map, and we're using magnetic measurements or bearings, and this is how you would read degrees or bearings off a map and on the ground. Both would coincide. Okay, if you're on the agonic line, which is where magnetic north and true north are kind of in the same direction, then you can use this technique. But anywhere else where there's a declination or deviation between magnetic north and true north, you have to adjust for true north, in which case this technique cannot be used. So here I would have to make an adjustment for true north, and I'm going to do that right now. Okay, so I've made the adjustment for declination for this area, and you'll see that magnetic north is west of true north, and the difference is roughly 20 degrees, okay, which is the declination, the westerly declination. Now, of course, I've got the compass aligned on the map, but the arrow is not seated in the red box, the red arrow box. So I need to rotate the map to seat the compass needle correctly in order to orientate everything correctly according to the magnetic declination. So I'm going to rotate the map here clockwise until the arrow is seated roughly in the correct position. Remember I said in the previous video, part of the video, it's actually, you're always going to get some inaccuracy when taking these bearings because of the area of parallax and various other reasons. So you just have to do your best in terms of accuracy. Okay, so now I've seated the needle in the red box, and now the map is actually orientated in the correct direction, so that we have the map facing true north as it stands according to declination. Okay, now I'm looking at the same map that I've just orientated, and if you look at that little dam there, that little water body there, and then at this one over here, you'll see that it lies, this one here lies 90 degrees or east of the first little dam I showed you. Okay, so the reading you would expect would be 90 degrees for a true bearing according to the map. Okay, remember, north is directly up at 0 degrees or 360 degrees, and east is going to be 90 degrees west. I mean, sorry, 90 degrees. Okay, so that's 90 degrees. That's the bearing you would expect. However, if I move to the other side of the map and I look at my compass, which I had orientated, okay, straighten it a bit, okay, which is orientated according to the declination, to accommodate for the declination, you'll see that true north is over there, okay, in line with the direction of travel arrow. Magnetic north is there, but east is actually 110 degrees. Okay, according to this. I've got the shakes, too much coffee this morning. Okay, so the real reading, if you're going now from the map to the ground, would be 110 degrees, not 90 degrees, which would be the true bearing. Okay, so the true bearing on the land, according to its position on the earth, etc., would be 90 degrees. But because you're using a magnetic needle, and the magnetic needle is reading off magnetic north and not true north, you have to make that adjustment, so the reading will be 110 degrees for an easterly direction and not 90 degrees. So finally, just to recap on what we've just looked at, we've orientated the map, we've looked at magnetic declination and how to calculate that over time, we've looked at how to set the compass for magnetic declination, and then to orientate the map according to that compass reading. We've also looked at a bearing taken from the map using this mathematical compass, okay, and then we've compared it to what a reading on the ground would be with a magnetic compass, which has been adjusted for declination. And because the magnetic compass is taking a reading using magnetic north as a reference, it's going to be different from a bearing taken on the map, which is using true north as a reference. So it's very important to keep that in mind. So anything on the map, once again, to summarize, is going to be a true bearing based on true north as a reference point. Anything that goes onto the ground is going to be based on magnetic north and therefore will be a magnetic bearing.